Welcome to The Explainer. Today, we're going to talk about something that trips up almost everybody who uses AI tools. You know that feeling when you use the same prompt in two different tools, but you get wildly different results? Well, there's a really good reason for that, and we're going to completely reset how you think about it by looking at the entire system, not just one piece of it.
So, whenever we're comparing AI tools, this is usually the first question that pops into our heads, right? We think, oh, is this one using GPT-4 or Claude 3 or Gemini? We automatically assume that the name of the model is the secret ingredient, the thing that will tell us everything we need to know about how it's going to perform.
But what if I told you that question, as logical as it seems, is actually giving you an incomplete picture? According to our source material, if you're only focused on the model, you're missing the real reason these tools act so differently from one another.
To really get this, we have to take a step back and think about how we learn new, complex things. We start with mental models, simple analogies to help us get our footing. But when things get serious, when the stakes are higher, those simple shortcuts just don't cut it anymore.
And here's the key distinction. Mental models are awesome for your first day. They're like the training wheels on a bike. They get you moving. But when you're in a professional setting, when you need things to work safely and predictably, you absolutely need a formal model, the actual detailed blueprint of how the system really works.
Now, what's so powerful here is how direct the source material is about this. This isn't just a friendly suggestion, it's basically a rule. The second you start thinking about risk or who's accountable, or you're just trying to figure out why a system did what it did, you have to drop the simple analogy. At that point, it actually does more harm than good.
And this just lays it out perfectly, doesn't it? You've got two different tools for two totally different jobs. On the left, you have your starting point for learning. On the right, you have the heavy-duty, accurate understanding you need for reliable day-to-day operations. You can't mix and match them.
Okay, so if just comparing the models is the simple mental model, what's the formal model we should be using instead? Well, this gets us to the absolute core idea of today's explainer.
This is so important. When you type into that chat window, you are not having a direct conversation with a large language model. You're actually interacting with a platform. And that model? It's just one component inside a much bigger machine.
So what is a platform really? Well, think of it as the entire system that sits between you and the raw model. It includes everything from the design of the user interface to all the hidden safety filters and constraints, and even the logic that decides which model, or maybe even which combination of models, gets to see a request in the first place.
Let's just walk through this. It's like a set of layers. Your prompt comes in through the user interface. That might kick off some retrieval to grab extra information. Then, it gets shaped and maybe even altered by a bunch of constraints and default settings. After all that, some routing logic decides where to send it. And you'll notice the model is the very last stop on this journey, not the first.
This is exactly why it all gets so confusing when you're trying to compare different tools. It's totally possible that two different platforms are using the exact same underlying model. So you'd think, hey, they should act the same.
But they don't, because the system built around that model is almost guaranteed to be different. Each platform has its own unique recipe of routing, its own set of constraints, its own UI, and that is what creates the different behavior you see on your end.
So why are they all so different? Well, it's because building one of these platforms is a massive balancing act. The creators are constantly making trade-offs. They have to weigh how easy it is to use against how safe it is, how much it costs to run versus how fast you get a response, and how well it can handle millions of people using it all at once. Every one of those choices changes the final output.
And this also explains that weird inconsistency you sometimes feel. You use a tool on Monday, it's amazing. On Tuesday, the same prompt gives you a garbage answer. Your first thought is, oh, they must have swapped in a dumber model. But the truth is, it's way more likely that an engineer just tweaked something in the platform, a safety setting, a routing rule, anything.
All right, so what's the big lesson here? What do we do with this information? It means we have to completely change our approach. We need to stop looking at one tiny component in a vacuum and start evaluating the entire system we're actually using.
Look, putting models head-to-head on some academic benchmark test might be interesting, I guess, but it's a terrible way to predict how a tool is going to work for you in the real world. Why? Because those tests ignore the huge impact of the platform that's wrapped around the model.
And this really is the bottom line. If what you want, what you need, is consistency and predictability, you have to test the actual tool you're going to be using, end to end. You have to treat the entire platform, from the chat window all the way down to the model,
as one single thing.
So I'll leave you with this question to think about. The next time you're comparing AI tools, or you're just trying to figure out why you got a weird result, ask yourself, are you just focused on one component, like the model? Or are you looking at the performance of the entire system you're actually interacting with? Because that shift in perspective, it changes everything.